Like class, we're on notes, section 7 of chapter 5. It's our last section. Kind of takes a turn away from polynomials and just talks about general ideas of what functions are, what they can do. You already know the notation f of x equals something. The whole idea is f for function because it doesn't have any practical use yet. If it were practical, then you'd replace f with whatever it stands for, something more practical. And f of x, so if we have, if we have, say, f of x, whoa, I've never seen that before. Did you know it could do that? Check that out. I don't know how to make it go back. There, woo! So if we have f of x equals 3x plus 2, and I want to know what f of 4 is, really what I'm doing is I'm throwing 4 into that function box and doing the math with it, right? It's not f times 4, it's not an equation, it's a rule. The rule is the f rule that takes the thing that you're putting into the box, multiplies that thing by 3 and adds 2. So if you throw 4 into that box, you're multiplying 3 times the 4, 12, plus 2, and getting 14. It doesn't matter what you throw in the box. You could throw 9 into the box. You could throw y into the box. You could throw a cat into the box, and what you'd end up with is 3 cats plus 2, right? It doesn't matter what you throw into the box. The rule is there. Okay, so we know that about functions. So what happens if we have two functions, an f function and a g function? What could we do with those two things? Well, maybe we could add them, or subtract them, or multiply them, or divide them. And that's what this section right here is all about. If I had the two functions f of x equals 3x minus 7, and g of x equals 13 minus 2x, could I add them together? Well, sure I could. All I would get when I add them together is f of x plus g of x equals, well, 3x minus 7 plus 13 minus 2x. That could simplify out. That's x plus 6. But the people in that big great building said, this is too much to write. That's way too much to write. Why don't we simplify this to say f plus g of x? And the notation then is been given to us. So all this means is you're taking the two individual rules and adding those together with that input of x. Now, interestingly, if I want to find f of 9, or let's do an easy number, f of 2, right? Well, what I could do is I could put 2 into the, if I want to find f plus g of 2, I could put 2 right here, 2 plus 6, and get 8. Or if I put 2 into this one, 3 times 2 is 6, minus 1 is minus 7 is negative 1. If I put it into this one, what did I say, 2? 2 times 2 is 4, 13 minus 4 is 9, negative 1 plus 9 is that same 8. So I can do the math early, or I can do the math at the end, and it's the exact same thing. So some difference, product quotient, don't get too bent out of shape about those notations. Really, all you're doing is just adding the two, or subtracting the two, or foiling, multiplying the two, or dividing the two, according to some of those things we've seen. Okay, so that's half of it, but don't let this half throw you for a big loop. The rest of it then becomes composite functions. Fog is what we sometimes call, because the notation is f with a small little circle, kind of like your degree symbol at 25 degrees outside, but brought lower right in the middle. It's not the letter O, but it kind of looks like it. And given f and g, the composite function f of g of x, f of g of x is f of g of x. You're going to take the g function and throw that into the box. Remember how before I said it doesn't matter what you put into that function box? You could put a 3, you could put an 8, you could put a cat. You could put an entire other function into the function box and simplify it from there. And that would give you kind of a nesting of things. There are all kinds of practical things that we can do with that. But trust me that there are some pretty good things. So let's talk about number 11 right here. Let's find f of g of x, knowing that the f function is x cubed plus 8, and our g function is x minus 1. So we're going to find f of g of x. So f of g of x. So the f function is the rule. G is what goes inside. So what is my f rule? My f rule says cube something and then add 8 to it. Cube something, then add 8 to it. Okay, so I'm going to represent my f rule, and that should match. Cube. This right here matches that function. I've got something cubed plus 8. Well, what am I going to cube? What I'm going to cube is the g function. The g is going inside that. So let's rewrite this. What is the g function? X minus 1. So that ends up being my answer. I don't really want to do any more than that. I just want to call that. In fact, do they? Yeah, they actually FOIL it out and do all kinds of crazy things with it. I'm happy with this right here. Turns out that we end up with just x minus 1 cubed plus 8. This is my composite function. And sometimes, hopefully, you can even see the identity of both functions. You see how x minus 1 is still that inside function? Do you see the overall general rule of this? The general rule is something cubed plus 8, and that is what we have. General rule, specific input. And that, I think, is all. No, I'm going to do one more thing with you. Those same functions, let's now talk about, well, what if you have g of h of 2? Well, there's a couple of ways you can do this. You can either create the entire g of h function up here with those three functions, or you can just evaluate it as you go. So this g of h of 2 is the same as g of h of 2. So just find h of 2. 2 goes into the h function. What comes out? Well, let's look at the h function up here. What is 5 times 2? That's 10. 10 minus 3, that's 7. So this is the same as g of 7. 2 goes into that function and 7. Okay, so now let's take the 7 and put that into the g function. What's 7 minus 1? That's 6. And g of h of 2 ends up being 6. And that is all there is to that. Play around with that and see what you get. And I will see you in a Google Hangout at some point. See ya.